Hello everyone, my name is David and today I'm recording this video. Let's get started. Mars is a disappointing hellhole lacking practically everything we need to stay alive. It looks like we ever have a small crease at miserable time and hidden underground. Except we could terraform it to a real new world. But to solve the planet's problem, we first need to make it worse and turn it into oceans of lava with gigantic lasers. This isn't far-fetched science fiction tale. Terraforming Mars is possible on the kind of time scale on our sensor built great monuments in if humanity solve the problem and ventures into space expand the ecosystem. This may not be that far off. Okay, so how do we terraform Mars so quickly? Well, it's complicated. Mars is dry and has no soil to grow anything. Its atmosphere is too thin to breathe or to protect from radiation, giving you a high risk of cancer. So to turn it into a new home on humanity, we need to give it a proper atmosphere, similar to Earth. Basically, 21 nitrogen, 21 oxygen, 79% nitrogen, and tiny bit of CO2. An average temperature of 14 and under a bar of 1 pressure. We have to create the oceans and rivers so the ground be weathered into fertile soil to host living things. We install biosphere on the surface to prevent it all from being undone and installing protective measures that can stand the test of time. It's difficult, but big lasers make it a lot easier. Challenge 1. The atmosphere. Some 4 billion years ago, Mars has a nice oxygen-rich atmosphere that had home to vast oceans and rivers. It's held on to it several 100 million years before it got blown away. Ultraviolet rays broke down the atmospheric gases and then oceans until they're swept away by solar winds. Today, Mars is a dry, barren wasteland. Luckily, there's a visible portion of water frozen in deep reservoir and polar ice cap, and enough to create a very shallow ocean, and ginormous amounts of oxygen are bound as minerals to Martian rocks, and the oxygen that must keep the planet's rust-red color, as well as carbon dioxide that carbonates. To free these gases, we need a reverse reaction that locks them away using thermolysis, which occurs temperatures as high as on the surface of the sun. In short, we want to melt Mars' surface. The best way to be put lasers in orbit, aiming the beams down on Mars. The most powerful laser today is ELINP, able to produce beams of 10,000 petawatt per second. To melt Mars, we need a laser twice as powerful that run continuously. The easiest way is to use solar-pumped laser that can be powered directly with sunlight. At its core, a metal-infused gas rolls up with energy and releases a laser beam. We build an array of mirrors into space, about 11 times the size of the United States. We can focus enough sunlight to melt Mars. So let's do it. As the laser hits the surface, several hundred kilograms of oxygen and some carbon dioxide emerge. As the lasers hit from every cubic meter of rock to melt, we have very efficient lasers, but only need to melt up the top 8 meters from the surface to get enough oxygen. It will look terrifying. The skies will be shrouded with storms, while the ground will glow red-hot, crisscross currents of lava. The tireless laser beams sweep over the landscape, leaving trails too bright to look at. After they pass, the ground cools quickly. A strange snow falls. Ashes from the elements solidify as they cool down, like silicon and iron. Mars is a cold planet at this point. The happy side effect is the inferior that all the water at the polar ice cap runs down deep underground and rises to the sky as hot as steam from the clouds that rain over the entire planet. They rush out the nastier gases from the atmosphere, like chloe, carry away the harmful elements and accumulate the surface in the end, which for shallow oceans saltier on Earth. We might need to do an extra cleanup before. So it will take about 50 years to continuous lasering to create an oxygen atmosphere. We could use this opportunity to dig deeper in places to basins for salty rivers and spare some landmark features like Mount Olympus and Valles Marineris. We're not done though. The resulting is nearly 100% oxygen and only 0.2 bar. It's harder to breathe and very flammable. To make it similar to Earth and a lot safer, we need to add lots of more nitrogen, which is Mars lacking sadly. The ideal source is Titan, a large moon of Saturn covered in a thick atmosphere that is almost entirely nitrogen. We have to move 3,000 trillion tons from the outer system to Mars. Well, that's not easy, it's doable. To process is not that Titan's surface. We have constructed giant automated factories on the surface powered by lasers to suck in and compresses to liquid. This gets pumped into a bullet-shaped tanks, which is a mass driver to shoot all the way to the red planet with the oxygen. We need to able to send individuals missions to Saturn with enough sources. We will able to possible test within 2 generations. So after a century at the start of the terraforming process, we have a breathable atmosphere that has the right gases. The liberated CO2 isn't enough to warm up the temperatures we can stand, as some coolant gases. Mars has this point resembles the black marbles from the cooling lava, spotted with glowing oceans and red patches, but the old surface remains untouched. It's still a wasteland, no better than a desert on Earth. We need to fill it with life. Challenge 2, biosphere. Installing the biosphere as a new planet is very difficult. We're expecting interactions between species and the sun. Disease can establish to a point of collapse. It probably began by seeding young oceans with plankton. Without competition, will boom rapidly, filling the oceans become the ground of aquatic food chain. Then followed by tiny zooplankton, then by fish, maybe sharks and whales. If things go well, life in the ocean will thrive. Life on land is hard. Plant needs nutrient-filled ground to sink their roots into, but most of the surface is concealed remains lava and ashes. We could wait for that 10,000 years, thousands of years for the water and wind to grind it down for a finer science and try to do it manually. But we want it to be quick. We have a big laser turning the beam on and off in rapid succession would cause the ground to quickly heat up and contract, which breaks it into smaller and smaller pieces. Add a bit of water and you get a sort of dark mud. Into this mud, it makes fungi nitrogen fixing bacteria. They are able to absorb nitrogen and convert it into nature compound to feed plants. So the first plants we're going to bring is native volcano islands on Earth. And they are perfectly suited to our laser blasted Martian atmosphere. Eventually, enriched mud becomes the foundation of grasses and forests. In Mars' lower gravity, trees can become very tall very fast. Their roots gather the nutrients, and they need to dig deeper to turn more rocks into soil, forming a self-sustaining ecosystem. At this point, we have suddenly introduced more plants and varieties, insects and animals, not mosquitoes. Well, the new biosphere needs to be maintained to prevent it from falling out of balance and slow too quickly and absorb too much carbon dioxide. The plants cool down too much. If the key species die out, they can see population collapse faster than they can recover. On Earth, other species will move into fill in the void. But our Martian biosphere is not as flexible. It takes hundreds of, not thousands of years before Mars becomes a stable environment. But eventually, the planet will have potential to sustain large human colonies. With air, water, and food available, we can finally call Mars black, blue, and green at home in space. A giant volcanic island in space. Will it last though? Challenge 3. Long-term future. There's a problem we haven't addressed. Mars core does not produce a magnetic field, so it does not have enough protection from the solar radiation of cosmic rays. This becomes dangerous for long-term health of Martian population. So as a final step, step 3, the artificial magnetic field. It doesn't need to be huge like Earth. It needs to deflect the solar winds enough so it doesn't touch Mars. The easiest way to construct a magnetic umbrella far away from Mars is the splashes winds to the side with a big under construction ring powered by a nuclear factory. That is all it takes. It'll keep orbiting Mars sun at one point, and between the sun and Mars protected from the new atmosphere, and that's it. Terraforming Mars will take some work, hefty resources, and probably a century or 10, but it will be the first time we live in home design and shit they solve for us, and the first step forward future among stars. So that's the end of the video. Thank you for listening. Goodbye.